Hey, welcome. Today we're looking at 3.8 compositions. So compositions are weird because of the notation. So there's two ways we can do it. This way with the parentheses. So we have F with parentheses, G with another parentheses with X inside of it. Or we have F with this, it's kind of like a circle. It looks like a dot there, but F circle G in parentheses, parentheses X. And the way we read each of those is that F composed of G of X. So it sounds complicated, and it probably is, and one of the barriers to math is the notation and the vocabulary of it. But all that means is that, and I like this left-hand version easier because it shows us exactly what's happening. So we're taking this function G of X and we're plugging it in to F where we have an X. Right, and then this form is a little bit different, but it says that F composed of G, so that means that G is inside of X. So one way to think about it, the best way to think about it is ask yourself, what is inside, and then what is outside here? All right, so the F in this case is the outside, and G is the inside. Okay, so let's look at an example. So it's asking us to, it's giving us first that R of X is equal to negative X plus 1, and S of X is equal to 2X squared plus 2. And it's asking us to find R composed of S composed of 2. So I know the X is missing, but what they're saying is let's plug in 2 here. So the easiest way to do this is start with the inside. So we're starting with 2 and we're plugging it into S of X, right? So 2 is inside of S. So let's do that. So let's do S of 2 first. Let's find out what that's equal to. So what that means is we're just going to plug in 2 for our X. Well, we're going to use our order of operations here. 2 squared is 4 times 2 is 8 plus 2, which is 10. All right, so we found S of 2, which is 10. So now we're going to find the R of that. So R of 10 is going to be equal to, well, we're just going to plug in 10 here. So negative 10 plus 1 is negative 9. So the answer to this whole thing is just 9. Now what we could have done is we could have plugged in all the things all at once and made it complex. But since we're starting off, let's start off the easiest way possible, and we're going to work our way inside out. Okay, let's switch up colors here. So this time we have S of X equals 2X minus 1 and T of X equals negative 2X squared plus 1, and it's asking us to find S of T of 2. All right, so again, let's find T of 2 first. That's the inside. So we're going to do T of 2. Here's your function. So we're substituting 2 in for our X. Again, order of operations says we do the exponent first. So 2 squared is 4. 4 times negative 2 is negative 8 plus 1, which is going to give us negative 7, right? So we're going to replace this T of 2 here with just negative 7. So we're trying to find now S of negative 7, which means we're taking this negative 7 and we're plugging it into our X here. So 2 times negative 7 minus 1 is going to give us negative 14 minus 1, which is negative 15. So that would be our answer. Okay, again, working from our inside to our outside. Okay, let's switch colors again. Now we're using purple. So U of X is equal to X squared plus 1. W of X is equal to square root of X plus 6. All right, so it's asking us to do U composed of W of 3. And notice they're using the different form here. The inside would be the W of 3. So we're going to do that first. So let's do W of 3 Okay, so we have 3 plus 6 in our square root. 3 plus 6 is 9. And I know that we've said in the past that we're going to do positive and negative for every time we square root, but in this case, I think it's only asking us for one answer. So let's just take the positive. So the square root of 9 is going to be 3, right? And then we're going to take that, and then we're going to plug it into our u. So then we're going to do u of 3, which is going to be 3 squared plus 1, which is 9 plus 1, which is 10. So we're going to put in our 10 there. Let's switch colors again. And then we're going to do the second one. So this time we're going to do u of 3 first. So u of 3 is equal to 3 squared plus 1. 3 squared is 9, plus 1 is 10, right? And then we're going to take that and we're going to plug it into our w. So w of 10 is equal to, I'm running out of space, square root of 10 plus 6. The square root of 10 plus 6 is square root of 16, and we'll say that's 4. Okay, so it's just kind of illustrating to you how u composed of w and w composed of u of the same number are not necessarily, in fact, most times they're not going to be the same answer. So it really matters which part is the inside and which part is the outside, and you need to make sure that you do it correctly when you're reading your composition. All right, let's do the next one. So q of x here is negative x. R of x is equal to negative 2x squared plus 1. This time we're composing q of r with negative 3. So remember the inside, right? This is going to be the inside. So let's do that first. R of negative 3 is going to give us negative 2 times negative 3 squared plus 1. It's going to be 9 times negative 2 is negative 18. Which is negative 17. We're going to take that, right? And then we're going to take that whole thing and plug it into q now. So, oops, that's a g, not a q. Q of negative 17 equals negative 17, which is 17. Okay, let's switch colors one more time. This time we're doing q first, right? So q of negative 3 is going to give us negative 3, which is 3. We're going to take that 3 and we're going to plug it into our r. Okay, so here we're going to get 3 squared is 9. 9 times negative 2 is negative 18. Plus 1, which is negative 17. Okay, so very similar, but not the same. Right? One of them is positive 17, the other is negative 17. But again, just practicing understanding the notation here, making sure that we do our right side first, that's the inside, right, and then plugging it into the other function. Okay, that's it for today. We're going to be doing more compositions next time, and we're going to be using them to talk about inverses. So again, if you have any questions, please bring them to class next time. We can talk about them and clear up your, we'll get your answers to your questions, and hopefully we'll be good then. All right, good job.